For my West Point Bridge design project, I named my company Tiny Trust Inc. because the bridge is very small, as you're going to see. For my design brief, Dungarvan Inc. is like a big bridge company within the U.S. in like Minnesota and Wisconsin. And so I did that one, and I just made, there's a scenario where miners have to cross the river to get to work. It isn't fast, they're going to be out of a job for too long. And then we just needed to create it that met all the requirements and criteria and is still cheap as possible. And then the minimization of cost, all the constraints, has to be flat, just the ones we've given. And then these were my flawed ones. This one was just too expensive. I was honestly kind of just messing around. I should use lighter materials, and it could have been better, like in the beginning. Like this was way too thick, and it was probably like all the cost. This one's like $250,000, and this one I was just messing around with the anchors on each side. Kind of looks stupid, but that one I was just also experimenting. This was my final bridge. When you drop it all the way down to water level, it lowers the cost, and then the cost of excavation kind of negates the material cost. My final was $174,019. I kept trying to get it to below 174 by like moving these slightly. I'm pretty sure this one is, like, it's not symmetrical, like this one's lower than this one. Because when the truck first gets on, if this one's lower, it just collapses right there, but it still allows it on that side when the truck's getting off. For my building materials, I used all quenched and tempered steel because it's the cheapest. I did use high strength steel for like these three right here, which I'm pretty sure are these three middle ones, because it needed the strength when the truck first got on the bridge. A lot of the stuff you just had to like mess with, like these are 170. I had all these as 170, but you can like slowly lower them and see. The quenched and tempered steels was the cheapest for that size, but it was also very like nitpicky because I could go to 45, but then it just gets more expensive. Or like I could go to 70, but it just gets more expensive. So like 80 was like that sweet spot between, or if you went lower, it'd get more expensive, or if you went higher, it'd get more expensive. This is the financial breakdown. You can tell like most of the cost was just the site itself. Excavation was $106,000 alone, and then connection, the steel, and then the, like, let's see, connection and steel were only like 28,000 altogether, and then just to buy the site and deck was also another 25. This is the full video. It goes like almost all the way into the water. And when you adjust this stuff and run it, you can kind of get the colors, like the darkest colors in your mind, how it like, they're all white, but then at some point they each turn red or the darkest blue as it goes across. That was one thing I kept doing to make sure I had the best design, I guess. Okay, I'll just go to this one first. My second bridge, I just kind of made one with a really strong bottom. I just wanted a bridge that didn't move at all when they went across. It ended up being $2 million. It's because I made everything bar and not tube, but I did that because I didn't want it to move at all. Which in the design brief I put Big City Bridge Inc. and they hired just to make a no constraints, no cost, just it cannot move. And so that's what I based that one around. And then here is the materials. Like I said, I didn't really pay any attention to what I wanted. I made it all quenched and tempered steel bar. And then I think, yeah, it's also all the same thickness. I kind of just messed around with the thickness. Because like at one point I set it to the thickest one and it was just a giant blob. But it didn't really look practical. This is the run. You can see it just kind of stands still. I was experimenting for this one with the where you would bring it in. I also did that for the first one because I guess there's one where you can, if you bring these sides all the way in, instead of excavating, you build up, and then you can build a bridge that's like almost an upside down U, and you can get a really cheap cost, but I couldn't figure out how to even get the function to work, because every time I build a bridge, it would just say not prepared, or like doesn't meet testing constraints or something. But yeah.
Okay.